Okay, today we're going to do 10-1, 10-2, and 10-3 all together because that's all areas of polygons. So we're going to start with parallelograms. And remember that parallelograms are just all four-sided, oh, I totally misspelled that, sided figures. We do not need the extra S. Okay, anyway, I meant to put four sides, I think. Four sides. Anyway, okay, so the area, so make sure and write this formula down. The area of a parallelogram is base times the height. Base times height. You might have heard length times width, that's fine, but for now we're going to use base times height. And the key here is to know that height is the dotted line. Okay, it's the height of the whole figure. So it's not always the dotted line. So if it's not a side, then it's a dotted line. So like on this first one, okay, your paper should have this in here, but I don't have mine in here. Okay, so here, and it always forms a right angle. So that's the key. Okay, the base and height form a right angle. Form right angle. That's how you know that it's the base and the height. That's because they're going to form a right angle. So this one, here's the right angle. This is a right angle over here. Any of these could be the right angle, but this is what's given. So the area of this figure is just going to be 6 times 5, which is 30, what did I say, inches? Okay, and area is inches squared. So yes, you need to have that, inches squared. Okay, if I don't have a unit on there, then let's just put unit squared, or we can make something up, okay? So on yours, we have, this is where the dotted line comes into play. Okay, so we have 7.8 here, we have 10 here, and we have 8 here. Okay, so you need to figure out what is forming the right angle. Okay, well we know that our height right here is the dotted line, so we know this is going to be our height, and it forms a right angle right here, which goes along with our base. Okay, so we do not need the 8. So area equals 7.8 times 10, which is 78 feet squared. Okay, so make sure you have that squared in there. So it's the dashed line and then whatever is forming the right angle with it. And it's the base of the figure. Okay, you don't have to add this extra part on here. Okay, we couldn't use this because this does not form a right angle. It's not a right angle right there. Okay, so we come over here, and on your figure, this height is kind of weird. It's going along sideways. And it tells you that this is 4, this is 11, this is 12, and this is 4. Okay, well again, our height is right here. It's the 12, even though it's flipped on its side, we have to use the 4 as the base. Okay, that's fine. The base is not always on the floor. Okay, so what is that? 48, and let's just say it's feet to make it easy. Feet squared, because I don't think I wrote it in on all of them. Okay, 48 feet squared. Okay, on this one, okay, I think it's just given to you that this is 8. This one's a little tricky because this is 8 feet and this is 2 yards. So you cannot just multiply those together. Okay, I don't think it's given to you, but we're just going to assume that this is a right angle right here. So 8 times 2, you can't do that because this is feet and this is yards, okay? So let's make this yards into feet. How many feet are in 1 yard? 3. So this is actually going to be 6 feet on this side. So now the area is 6 times 8, which is 48 feet squared. Okay? This one, they're all right angles and all the sides are the same, and it just gives you 1. Okay, so you can either do 7 squared or you can do 7 times 7, which is 49 inches squared. Make sure you put the inches squared. Okay, so parallelograms are just base times height. Now when you look at triangles, what do we know about triangles? Hopefully you guys know this. If you take a parallelogram and a rectangle and you split it in half, what do you have two of? Now you have two triangles. So if you take the area of a parallelogram, which is base times height, and you split it in half, divide it by 2, then you have the area of a triangle. Or more commonly, it's 1/2 base times height. It's the same thing. I don't care what you do. It's the same thing. Okay? So in our picture here, we have, again, our height is perpendicular to our, forms a right angle to our base. Okay, this really comes in handy on these triangles because our height here is 4, but our base, we have to know our height is perpendicular to our base, so it'd be 8 times 6 divided by 2. And 6 and 4 is 24 divided by 2, so 12, let's just say it was feet squared since I didn't label it. Okay? Now this second one, it's given to you, that's not a dashed line because it's the actual side. Okay? So these form the right angle, so that is our base and height. It doesn't matter which is which because they both form the right angle. So 6 times 7 divided by 2 is our area. Okay, 6 times 7 is what? 42 divided by 2, which is 21 feet squared. There we go. Excuse me. This one, we have a dashed line here, and we have, this is 3, 9, 10, 8. Okay, so again, base times height. Okay, well right away we know our height is 9 and it's perpendicular to this side right here. So 9 times 3 divided by 2, which is what? 27 divided by 2, which is, it's okay to have a decimal here. What, 16? No. 13. Hello. 13.5. Let's say feet squared. Do I have it labeled? No, feet squared. Okay. And then if we go, this one on your paper, it's already labeled like this. 12 feet here, 15 feet here, and 9 feet here. So again, our height is what's perpendicular to the base. Again, the base is not necessarily on the bottom. Okay, just because it's the base doesn't mean it's on the bottom. So 12 times 9 divided by 2, whoops, so area equals, so if you want to think about it, it's really 6 times 9, which is what, 54 feet squared. There we go, or 12 times 9 divided by 2. Okay, moving on to the next one. The next one is trapezoids. Now trapezoids are a little bit harder. Okay, it's not real difficult, but we tend to forget what to do. Okay, so what we need to remember is there's two bases. So there's base 1 and base 2. It doesn't matter which one's which. The height connects the two bases. So this side and this side are not important. Okay, it's not that they're not important, but they're not important to the area. We don't really need them. All we need is the bases, which are parallel. So there's a few things on this. Bases are parallel. Okay, and the height connects the bases. Okay, so the formula here is area equals 1/2 the height times the two bases added together. Base 1 plus base 2. Again, this is just so you know the difference. It's one of the bases plus the other base. Okay, so if we look at our pictures, right away you should be able to say, okay, which one's my base, which one's my other base, which one's my height. Okay, so right away we know that the bases are the two that are parallel. It doesn't matter where it is in the picture, the two that are parallel, and the height goes in between. So area equals 1/2 the height, which is 12, times 24 plus 33. So there's different ways to do this. You can go ahead and just multiply the height. What's half of 12? 6. And then add the 24 and the 33. So 4, 5, 6, 7, 57 times 6. Okay, so if you want to write that out, or you're allowed to use, it's 342. You're allowed to use your calculators on this. 342, does it say, millimeters squared. Okay, now this one, it comes right here, and we have 4 feet and 3, oh, that's kind of messy, 4 feet, 3 feet, and 6 feet. Okay, so again, we don't need these sides, but we do 1/2 the height times 6 plus 3. All right, so 1/2 times 4, which is 2, and then 6 plus 3, which is 9, so 2 times 9, which is 18 feet squared. Okay, now this next one. Okay, we have our 2 right here. We have our height coming here. 8, 4, 4.5. Okay, again, do we need this 8? Okay, these are our 2 parallel. So 1/2 4 times 2 plus 4.5, or 4.5 plus 2. It doesn't matter the order. So 1/2 times 4 is 2, and this is 6.5. So what is 6.5 times 2? Well, 6 and 6 is 12. Okay, so is it going to be 13? I'm looking at all my... Okay, so 6 and 6 is 12, and then you have one more, or 2 more halves. So 13, no, I don't have a label, so let's just say feet squared. Okay, so there's a few more steps on this one, but it's still not overly difficult if you can remember the formula. Okay. Oh, wait, do I not have... Oh, I didn't put it on here. Okay, I might have to add some more at the end. We'll do those in a minute. Okay, the circle. Okay, area of a circle. Okay, so area of a circle, if you remember, area is pi r squared. So you have to have the radius. Okay, now you can use 3.14 pi or 3.14. I don't care. I think it's easier to use the pi button, but I don't care at this point. Okay, so this is 12. Okay, so pi, so this is our diameter, so our radius is 6. Okay, so pi 6 squared, which is pi times 36, which is 36 pi, whoops, which is 113.097. I'll just go to that many decimal places. And it's, again, it's whatever it is. Oh, I did do feet squared. Area is always squared. When we get to volume, it'll be cubed. Okay, if you use 3.14, it's your decimal is gonna be a little different. That's fine. Okay, next one. The radius is actually given. Okay, so you don't have to do a lot. Pi 8 squared, and you can actually put it into the calculator like that. Pi 8 squared. You should get 200. You can just put it just right in there like that. That's why I think it's easier to do it. 0.62 if I round. Feet squared. Okay. This one right here is 20 feet again. Okay, so you need the radius again, which is 10. So again, you can put pi 10 squared right into your calculator. Which all you do is move your decimal over on pi, but that's okay. 314.16, because it would round. feet squared. Don't forget the squared. Okay? Now this one, you got to add a few things together. We have 8 here, we have 10 here. Okay, this is really all the info we need for this. Okay, because we can find the area of this rectangle by just doing 10 times 8, which is 80. And then we can find this semicircle, because what's the radius? The radius is 4, because we know this is 8. So if this is 8, this whole side is 8. So the area of a circle is pi 4 squared, okay, which is, which is 50.265, we'll say. But that would be if it's a whole circle. Is it an entire circle? It's just half a circle. So we're going to divide by 2. So divide by 2. I actually just divided in my calculator, so it's going to be 25.133. Okay, because I didn't round it off in my calculator. And again, it's feet squared. So you kind of got to break it up into shapes you know, and then go from there. So here, this whole big line is 14. Oh, I forgot to shade it. Whoops, that's one thing. I forgot to shade mine. Okay, so we want to find the area of the shaded region. So we're going to say this little region in here is shaded. Okay? So we want to find the area of the shaded region. Okay? So, actually, let me look at something real quick. Oh, I did it the other way. Well, it's fine. Okay, let's say we want that area. Okay, actually, let me change it. Sorry. We're going to say this. We want the blue area. Okay, we want the blue area. Well, to find the blue area, we need the area of the whole thing, and then we need to subtract it from the area of the little, or subtract the little one from the big one. So the area of the big one is going to be 4 pi r squared, so 14 squared pi, which is, the area of the big one is 615.75, the area of the whole thing. So we want to subtract the area of that whole thing by the area of the middle. Well, how do we know what the area of the middle is? Well, we know the big radius is 14, and we know this little radius is 7, so we also know this middle one right here is 7. Okay? So you could just maybe divide it by 2. I don't know if that would work. So 7 squared, pi 7 squared. Oops, I put m instead of pi. Whoops. My mind is still on spring break. So this is minus, so it's not half. That's good to know. Oh, shoot. I always do that. 153.94. Okay, so we need to subtract 116.75 minus 153.94. So the area of the blue is 461.81 millimeters squared. Okay, so we wanted the area of the blue, so we took the big area of the whole thing and subtracted the area of the little one. Okay, and what's interesting is that I find that the area of the little one is not half the area of the big one, even though one's 14 and one's 7. Okay. Yeah. Okay. You guys can check my work on that one because I did not have that one done in my notes. Okay, I would like to add, yours is already on your picture. Okay, but I'm going to draw it on here real quick. I would like to add these two that you have, but I don't. See if I can get this. Okay, good enough. Okay, so we have a rectangle that's 15 by 10. And then we have this little triangle that's 2 by 3. So go back a page, and we're going to find the area of the shaded region around the triangle. Okay, so again, we have to do the area of the rectangle, which is 15 times 10, which is 150. And then we have to subtract the area of the triangle, which is 2 times 3 divided by 2, which is just 2 times 3 is 6. 6 divided by 2 is 3. So if we subtract these, it would be 147 feet squared is the area of the shaded. Okay? And then this next one, oops, that's supposed to be a square. It's all right. Looks like this. With the height here. So we have 2, we have 6, we have 3, and we have 5. Okay, so we know the area of this square is just 5 times 5, which is 25. And then the area of the trapezoid, okay, remember, is 1/2 the height. Which one's the height? It's the 3. And then times the bases. Well, what are the bases? 2 and 5. So that 6 isn't needed. Okay, so 1/2 of 3 is 1.5 times 2 plus 5, which is 7. What is 7 times 1.5? What? Don't make me do a fraction. 10.5. Because it would be 7 plus half of 7, which is 3.5. That's where you would get that. So 25 plus, I don't know if I said minus earlier, because we're finding the area of this whole thing on this one. So you would actually add it together. So 35.5 feet squared would be how you did that. So sorry that wasn't on there. I don't know what happened. Okay, I think I have a little comic for you.